Oh,
Huh?
oh, there you go. That's good.
Yo.
Yo.
I think an update. It was like failing update or something. My
Oh,
bad.
okay. No, you're good. All right. We are live. All right. Shit this daily. Find all k distant indices in an array. Let me share my screen.
I can share my screen too.
All right. Okay. So we are given a zero indexed integer array, nums, and two integers, key and k. So a k distant index is an index I of nums for which there exists at least one index j such that the absolute value of I minus j is less than or equal to k, and nums at j equals to key. I okay, wait. I'm confused. Let me so index so okay. An index I of nums for which there exists at least one index j such that I absolute I minus j is less than or equal to k, and nums at j is equal to key.
Mm-hmm. Yeah.
Jesus. Okay. Um. Okay, wait. I gotta like make sure my head is wrapped around this.
Mm-hmm.
So. Oh, okay. Well, okay. So for any given. Oh my god! Wait, I'm loud. So for a given index I, um,
Mm-hmm.
it may have a k distant index, which is so okay. So the item has to be at least k like items away from like I. So j has to be at least k away from I,
Mm-hmm.
and the value at j has to be equal to key.
Yeah.
Okay, I see. So let's see. Um, let's take a look at the example and make sure I have this correct. So we have nums here, which is this list, and our key is 9 and k is 1.
Mm-hmm.
So, oh, sorry, and our return has to return a list of all k distant indices sorted in increasing order. All right. Wow. Um, okay. So basically, I think what we're looking for is the the values that are like starting from key,
Mm-hmm.
right? At least k away. So let so since the key here is 9 and our k is 1,
Yeah.
All values that are at least one away
Mm-hmm.
are are k distant indexes, right?
Yes.
So
Yes.
j is key, right? Or yeah, nums at j is key, and that'd be 2 here.
Mm-hmm.
And so these are valid because they're at least one away.
Right.
Like, right? And then same with these, all these values.
Mm-hmm.
And then we also have another key here, and these are all also valid.
Yep.
Okay, cool. So, all right. Okay, so this is making more sense now. What I'm thinking about doing is right now, at the very least, I know that we need to find all the instances of key in nums, right?
Mm-hmm.
So that we can find, any valid indexes like around it.
Yeah.
Okay, so our first task, I guess, is to find all I guess instances of key. And so I'm trying to think of possible solutions, or possible data structures you could use here. Maybe okay. I feel like I don't know if this is like how to use a sliding window properly, but like I'm thinking right now, right? We have k, which is 1, and so
Yeah.
that means that we know that from key, no values from that are 1 away can be valid, right? And so we'll have, I'm thinking like a left and a right. Okay, maybe this is not sliding window, but like using pointers. But like let's say we start from here. We start from the left, and we have a left pointer that is 1 away from. Then we'll have a middle pointer, and then our right pointer will be k away from. So we'll have a left pointer which will be k away from the middle pointer, and then we'll have a right pointer which is k away from the middle pointer. Does that make sense?
Yeah.
And so we're going to basically move this entire window that we're looking at, and we're gonna iterate through until middle is equal to key, or nums at middle is equal to key. And so by doing that, we know which values are not valid. So everything inside from L to R, all those indexes are not valid. And so we can store the rest, everything from 0 to L in the output, and everything that's from R to length of nums minus 1. Does that make sense?
Is he saying everything within it
Everything
would not be valid?
Yeah. Wait, I minus j. has to be less than or equal to k. And then num set. Oh wait. Oh, I think I may have. I might have said has to be less than or equal to k.
Yeah. You
Okay,
might
wait.
have flipped it.
Yeah. So sorry. Everything that's inside of this is valid.
Mhm.
Right.
Yeah. Mhm.
Okay. I'm gonna choose this equal to k, and then I'm such a k. So does my approach make sense though? Like we just have that going until middle is equal to key, and then everything within that is valid.
Mhm.
Okay. So let me just make sure. Okay, yeah, and I guess this would also include key itself. So that's why 1, 2, and 3 here are valid because
Yeah.
from the first 9, and then 4, 5, and 6 are also valid.
Yes.
Okay, cool.
Do you want to take a look at example 2, how that would play out?
Right. So if I use the same approach for example 2, we would have a left pointer at 2 here. And then that would go to 2, and then we'd set the middle pointer to the middle here. And then 2 more away would cause the right pointer to be at the end.
Mm-hmm.
So everything within this would be valid, right?
Yeah.
But then I guess maybe what you're trying to get at here is when you are iterating through the rest, you don't want R to be. Oh, actually, let's see. Cause they're okay. So for a second there, I was thinking like, oh, like we could stop it when R is greater than the length of nums minus 1, but that wouldn't work in the case where it's at the end or like it's within the like these two, for example.
Mm-hmm.
So what I'm thinking is we somehow like shorten the right side
Mm-hmm.
until until middle reaches the end, or actually maybe it might be easier to just keep track of k values. So sorry, like we'll have just like one pointer, I guess, right?
Mm-hmm.
And as we're iterating, we're gonna keep track of k values like that are behind. Oh, sorry, that are k values like behind.
Yeah.
And so then we can just add like whatever else after that is less than or equal to like the length of nums, if that makes sense.
Yeah, that makes sense.
Okay. And so this would be O of n, because we're iterating the entire array once. And I think we could use a set, I guess. In the case where like let's say k was equal to 2 here.
Mm-hmm.
We'll have some overlapping values, and so we could just use a set and then turn it into a list at the end, to keep track of all the valid indices.
Yep, that works.
Okay, so I'm just gonna create this answer set, and then at the end we are going to be returning this this set as a list, and and I assume that it will end up in increasing order, but could be wrong. I think when you turn a set into a list, it is in that order. But I could be wrong. But okay. I'll just, I don't know if that's like, but like that's just something I wanted to note for later.
Yeah.
Okay, so like my approach said, we're just gonna have a moving pointer. So we're going to iterate through the list, and we're going to have a middle pointer, or I guess just a pointer that starts at the left, right? And so as we're iterating through this list, we're going to have a left pointer, or I guess, something that keeps track of pointer minus k. So okay, sorry. We're gonna set this to like pointer minus k, and then like if left is less than 0, then we just set left to 0, right?
Yeah.
And so as we're iterating through the list here, my plan was to check if nums at I is equal to key, right? And if that's the case, then we add ants dot is append what we use for sets.
Sets should be add.
Okay, sorry. So ants dot add everything from left to right. So I guess we'll have to like loop through it. For I in range pointer minus, or I guess, sorry, we don't even need pointer. Oops. Because our pointer is just the index that we're at. So for j in range, for I minus left, right? We're going to inst.add j, and that should be, it should add everything from left to I, right? So left, or right? Because I think I would be like 2, right? And then left would be like 0. So in range 2, so that would add 0, 1. Does it not? Does range include the last item or no?
No.
Okay, so we can just add +1. I think. Oh wait, no. That's not right. We're gonna add plus. Hold on. sorry. So we're gonna add from left to I. So with range, can I do like from left to? Is that how do I? Can I use range like that or no?
It'd be a comma.
Huh?
It'd be a comma.
Oh, okay. Sorry. Like that, and then it would include the last one, right? So we want to include I. And then we'd also need to add I plus left, maybe? If that makes sense. Because...
Y left.
Or I plus K. Sorry.
Yep.
Inside J. And that will go to the range plus 1, I guess. Right? Yeah. Okay. And so I think we also need to move this into here, but that's kind of not super important for now. Alright. And so this... Yeah, I'm kind of just like coding this out. Like I didn't even like really add to code. But, alright. So, let me make sure this is right. I don't know. I feel like I'm missing something, but... So, I'm going to iterate through the list. And I'm going to set left to equal to pointer minus k, or I guess just I minus k, right? And so I minus k is going to be less than 0. So we're setting left to 0 here. And if num's at I, which is 0 here, equal to key, it's not, so we're going to iterate again until we hit 9. And so 9 here, I would be 2 minus 0. So that'd be negative. Oh wait, so sorry, that'd be 2. And then, wait, hold on. Oh, sorry. This would be 2 minus 1. So left is now 1, right? And then, so if num's at 2 is equal to key, for j in range 1 to I, which is 2 plus k, which is 1 plus 1 to 3. This 3 here. We're gonna add and set. We're gonna add j, so that'd be 1, 2, 3. Okay. And then this should return as a list. Let me make sure that this should work all the way through with 2s. So let's say after it collects the 2s here, all these 1, 2, 3, 4, or 0, 1, 2, 3, 4, it'll iterate again, and we're going to set left to I minus k. So I is 3 minus 2 is 1. So left is equal to 1, which is here. So this should be left. And then for if num's at I is equal to key, which it is, for j in range left, from left to, so it's going to add it again, which is kind of redundant, but it's okay. And then I guess when it gets to the end, wait, sorry, I skipped ahead. So for I and j, from left to I plus k plus 1, which would be 3 plus 2 plus 1. But this is, so instead of this, we can do right equals and then if right is greater than length of nums minus 1, right equals length nums minus 1, right? And then we just put this as right. So yeah, so I plus k plus 1. Otherwise, there's definitely like a more cleaner way to write this, but this is like simple and straightforward. So
Yeah.
all right, and then so yeah, it'll set right to this. It'll add it, bang, and then for the final one, same thing. If right is greater than length of nums minus 1, such length of nums minus 1, bang, bang, bang. Okay, I think this should work. Iterate the list. So for I in is this right? Or just is there anything that like really like sticks out to you?
I think there is one thing that can happen.
Okay.
No, but I think you address that, so I think it's fine. Yeah.
Okay. Alright, cool. Let's try.
Yeah,
Let's try
like
right.
a one-off. Because with range and stuff, it's always tricky. Yeah. Check your right. Check what happens with right. So what do you set right equal to?
Oh, we set it to length of, but it doesn't include it. So we do this.
Yeah, or you can just make right length and nums, and either one works. I think.
Oh yeah.
See how,
Yeah,
like,
that's true. Or
wait,
well,
that one. You set right equal to just length of nums.
this. Or no, like this bottom one, right?
Yeah, yeah.
But
I could be tripping.
oh, I see. Wait, hold on. Oh right, because it's always at the end. But I already addressed it with this one.
Yeah.
Okay. All right. Cool. All right. Just do. Yeah. It doesn't matter. All right. All right. Let's just submit. Bang. Did not deal with the edge case. I'm fucking stupid. Oh, sorry. All right. So edge cases is just what?
What was the area? Okay.
So with one, let's just use that. So with 1, our key k would be 1. And so what would happen with my code here is that for I in range, like the nums minus 1, which is 1, we're going to set left to this I, which is 1 minus k.
What's length of nums?
Huh?
What is length of nums?
Oh, it's 1, so that it would be in range 0, which is nothing.
Yeah.
I see. So
what if you get? So why are you doing -1 there? Why are you doing length of nums and -1?
Because oh wait, no, that's it. Because I don't want it to include. Sorry, all right. So I did -1 because I thought like I kind of did it on like instinct, I guess, but like just because like range of length of nums minus 1, it would be like the last element, but then I forgot that range it like
Yep.
it excludes the last item.
Mm-hmm.
Okay.
Nice.
Ugh.
Woo!
Woohoo.
Good
Oh
stuff.
my gosh.
I think the only thing that I would have done different was I would just have used min and max. Because there's like just a bit of repetition when you use the set, right?
Right.
Because you see like the example 2,
Yeah, because it's just
you're like adding each of them like a bunch of times. So if it's
uh-huh.
like a really, really long list, then you're probably looking at some of them like many, many times, especially if your K is like really big, right?
Right, right.
And it's gonna be like counted so many times. So
Uh-huh.
if you don't use a set and you like convert to list at the end, then like your goal is how can you just like look at every single index once, right?
Yeah.
So actually I can let me share my screen. I can
Sure,
do
sure,
it.
sure, sure.
I haven't written anything out yet, but
Alright.
I was just thinking about it while you were doing it.
Alright.
Um, yo. Oh my god. Bro, it's only showing Google as an application when I switch to the slide. I fuck the entire screen.
Okay, cool.
Also, I don't even know if this is like what the fast version was,
Alright.
but I will still go through the entire thing, and then I'll also still keep a left pointer and just set it to like 0,
Yeah.
I guess. Right. And then again, every time you hit the key, so if nums I is the key, then we want to go from right K before all the way to K after I.
Right.
Oh, so we also need to answer, right? And we just make it a list.
Uh-huh.
So for J in range, and so this is going to be other index. And so
Oh, I see. Yeah.
here I would do like
And then
yeah, or a max. Right.
right.
So
Max of
yes,
left and
yes.
yeah.
You're not like duplicating all the ones that
Uh-huh.
we're already at.
Uh-huh.
So it would be like max of left
And yeah.
and what I minus K, something like that.
Right.
That's probably like relatively right. And then you go up to I plus K plus 1 or whatever.
Right.
And then you would just answer dot append J.
Uh-huh.
But then you would also do I think just to make sure you don't go past the end, then you do the min of this and length of nums.
Okay. Yeah.
And then each time you just set the left equal to it always go past the end, so I plus K plus 1.
Right.
That might be like slightly off, but oh my god. Something's probably wrong. Oh. LFG, I guess. Boom.
What the
All right.
fuck, bruh? Okay, cool.
Yeah. Okay.
Wait, for some reason I was thinking that setting left to I plus k plus 1 would be...
Yeah, I thought it would have put it like 1 too far or something.
Yeah.
No, yeah. Like this is, I would never just run this. I would always go through everything because like you have so many, especially with range,
Yeah.
right? Like you're always thinking about, oh, do I include the end? Do I not include the end? And like all the
Yeah.
+1 and -1 like really trip you up. So
Yeah.
we expect this to fail by like some sort of error, but
Uh-huh.
I guess we're chill. But yeah,
Wow.
I think if I was doing it like without thinking while you're doing it, then it probably would have been more inefficient for sure.
Yeah.
But like seeing what like while you were talking, I would think about, oh, how could I
Right.
maybe make it better, and then yeah, but I did not just think of this off rip.
Right.
I think initially what I was thinking was like first like just getting all of these, right, storing all these indexes,
Uh-huh.
and then doing a similar thing where like, okay, for each one of them just go from like k before and keep going,
Yeah.
and then store that like max, go to the next one, and then go from that max until the end. So it's like
Yeah.
kind of similar. Got to go through it like another time.
Yeah.
But yeah. But then seeing you like just go through each one at a time and then going for, then I was like, oh, I can just do that instead. So
Right.
it's slightly different, but
Uh-huh. Okay, cool.
this is a good one.
That was a pretty good one.
I mean, even though you use the set and it like made it slower slightly, at least like you know how to use a set, and like you're gonna use it to get rid of duplicates and stuff like that.
Right.
So at least you know the use case of that.
Uh-huh.
So not bad.
Alright.
But yeah, I mean, I feel like you're definitely getting more like confident, and like writing out the pseudocode
Uh-huh.
definitely helps, because at that point you pretty much like already just wrote it all.
Right.
But yeah,
Okay.
and you also mentioned time complexity, right? You said Van.
Yeah.
Mm-hmm.
Alright. Kind of want to tackle like a sliding window problem because it's been a while, but if you're down,
You gotta go
you have
eat dinner.
Okay. Alright, that's cool. Alright.
Yeah,
Alright, you can step. No
All right.
problem.
that's good stuff though.
All
All
right.
right,
Later.
I'll see. Peace.
Peace. Okay. So I'll just be doing this by myself, I guess. So, you are given an array prices, where prices at I is the price of a given stock on the ith day. You want to maximize your profit by choosing a single day to buy one stock and a different day in the future to sell that stock. Return the maximum profit you can receive from this transaction. If you cannot retrieve any profit, return 0. Okay, so we have this array prices, and the price of the stock on day I is the value of the list at that index. So what we want to do is we want to maximize our profit to choose a day where we buy a stock and a different day later where we sell that stock, right? So that means for given our prices, we need to find the earliest day where we can buy at its lowest and sell at its highest. So, you know, a lot of people, I think, would approach just like, oh, we find the max, right? And we subtract that from the min. But this wouldn't work because we would need to sell before we bought, which is not possible. Which is kind of what the explanation is telling us here. And so what we need to do is keep track of what we can or can't sell, or like what we can like buy or sell, right? And what I mean by that is, or like, well, okay, let me just kind of explain. So this is a sliding window problem, right? And what I mean by that is, what we're going to do is we're going to start at the beginning, right? And we're going to check, and we're going to set the very beginning from as the min and the max, right? And so we're going to keep going, and if we find a value that is less than our current minimum, we set that to our new minimum, right? And if max is behind that, then we kind of just push it all to 1, right? So now we're starting at 1, and we're going to go here, and we're setting our new and we're going to check this next value, right? If it's less than our current minimum, then we set it to our new minimum, and we keep checking. However, if it's greater than, then we set this to our max, right? And we keep going, right? We're gonna continue to the next element here. It's 3, but then we're going to notice that our profit is less than if we subtract 3 minus 1, right? So we're gonna continue, and we're gonna reach 6, right? And now our new max is gonna be 6 minus 1, so our rate of start is gonna be 6 minus 1, and then we're gonna go to 4, and it's gonna be less than 5, which is our new max profit, and we're going to reset. So this is kind of the same thing here. So we're gonna go to 7, right? And we're gonna go to 6. 6 is less than our current minimum, which is, or I guess our left, right? So we're gonna start at 6. Okay, this is our lowest value we can buy at, right? Boom, 4. Okay, that's the lowest value we can buy it. Boom, 3. This is the lowest value we can buy it. Boom, this is our lowest value you can buy it, right? So if we ever achieve, we can keep track of our maximum value, but once we ever hit a value, let's say 1 was not here, right? Okay, well, it's kind of a bad example. Let's say like it's so weird. Let's say we had a list where our minimum got moved after we calculated a new max profit, right? What would happen is like, let's just say like we have 1, 2, or okay, let's say we have 2, 4, 1, 5, right? 2, 4, 5, and then we'll have like 1, 6. Sure. Something like this, right? So we're gonna start here at 2, and this is our minimum, and we're going to the next value, right? And that's our new maximum is 4, right? And then we're going to the next value. Oh, our new maximum is 5, right? And so once we hit 1, this is going to be our new minimum, but we continue to hold that our current max profit was 3, but our new minimum is 1, and we're going to see if any values after that will produce a max profit that's greater than 3. If we do, then yeah, but we never need to check anything before that, right? Ever again. And so since this is our new min, and we have to sell after this new min, but we've already kept track of the greatest maximum profit before we hit our new minimum. All right, so this is 6, our new maximum would be 5, and we can just replace this, right? But if it was like 3, for example, our new maximum, so our maximum here would be 3, but from our new minimum, or the max profit we get from selling after 1 is 2. But we already kept track of this, so we can just use this previous value. All right, so let's solve this problem, right? So we are going to have a min, or we're going to have a left and right pointer, which represents our minimum and our maximum. And we're going to set that to 0 and 0. Right? And while R is less than length of prices, we're going to yeah, and so no matter what, we're going to have to iterate R. So what we're gonna have to do is we are going to and we're gonna have also an int value here, which we're going to set to 0, and we're going to return ints if we can't get a max profit greater than 0. So what we're going to do is we're going to check first if R minus, or if prices at R minus prices at L is greater than ants, then our new ants is this prices at R minus prices at L. I mean, that's fine. We have that, and what we're going to do once we check that, is we are going to increment R, and we're going to check if, okay, so sorry, let's just do, so we're gonna need to check if R plus equals 1 is less, so okay, once we increment R, we're going to check if R is less than, or prices at R is less than our current prices at L, right? And if it is, what we're going to do is we're going to set L to R. Yeah. We're going to set L to R. And so what this loop should do is we're going to check if prices at R minus prices at L is greater than ants, then we change our current maximum to this difference. We're going to increment R, and then we're also going to check if prices at R is less than prices at L. And that, if that's the case, we set our new minimum to this, and we're going to continue going through it, right? So now our new maximum is 1, and if R minus L is greater than ants, which is not, we're going to increment R, or we're going to, ants doesn't do anything, and then we're increment R one time. So now we're going to check if prices at R is less than prices at L. L is equal to R. It's not, so we go back up here. Finally, we're going to get this prices at R is greater, minus is greater than ants, so now we're changing our ants to 4. Increment R. So now this is our new window. And we're going to check if it's less. Boom, boom, boom. We're going to get to 6. 6 minus 1 is indeed greater than 5 minus 1. So our new ants is 5. We're going to increment R, blah, 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 and we're done. So this should work with this case too. Let's try this, example 2 here. So we're going to set 0, 0, 0. R is less than length of prices. And so we're going to check if prices at R is less than prices at L. Sorry, if prices at R and minus price at L is less than N, it's not. So we're going to increment R. And then indeed it is less, so our new L is 6. And this is going to be 4, and then it's going to be 3, and then it's going to be 1. L minus R. And then we're going to go through this one more time. It's not. It's going to increment R. R. Prices at R. If R is less than, if length of prices minus 1. Alright. This should look right. Let's also make sure we do the base case or edge case where we have just 1, right? So let's say our case here is just 1. What would happen is we're going to set L and R equals 0, 0, 0. Length of prices, so that'd just be well, R is less than 1, which it is. Prices at 0 minus prices at 0 is not going to be greater. We're going to increment R, and we're going to check if R is greater than length, or if R is less than length of prices, which it is not. Then we're going to skip this, and we're going to get back here, and now R is outside, and this should work. Let's run it. Boom. And passes the 1. Awesome. So we successfully used the sliding window. How could I be more efficient here? Alright, so this is so stupid, bruh. They're actually that's actually fucking hilarious. So let's see what is faster. So if P in prices, if P is less than minimum price, set it else if P minus minimum price is greater than max profit. Oh, that makes sense as well. So instead of keeping track of our L, what we could have done is we just do a for I in prices, right? And if it's oh, or we keep track of a min, and if it's less than our current min, we replace it. Otherwise, we just subtract our current index minus the minimum, and if that's greater than, then we set ans to that. Bum bum bum. Yada yada yada. Whatever. It's O of n regardless. it's not too crazy, so I'm not upset or anything. So good job. We have successfully completed double-digit problems today. I'm happy with that solution, and I will see you guys in the next stream. Thanks for watching. Bye bye.